Okay, this video is the blue ice activity. What I'm going to do is go over the setup with you and then start the experiment so that you can see the data that's being collected. On the left-hand side, this is beaker 1, and on the right-hand side, this is beaker 2 from the original blue ice progression. What I have in here is I have a setup with 2 temperature probes in each beaker. One of the temperature probes is at the bottom, and one of the temperature probes is at the top. Now, it's up to you to kind of decide what's the purpose of having 2 temperature probes and why are we measuring temperature in 2 different places. And remember that the blue ice activity is here for us to determine why one ice cube melts faster than the other. So over this reaction process, you're going to have to think about how to explain why one ice cube melts faster than the other. Use the data from the video in order to do this. And what I recommend you do is kind of set a timer as I put the ice cubes in, so that after so many seconds that you're recording the temperature. The temperature probes, you're gonna see, if I touch this one here, might take a minute just because I've got a pair of gloves on. Okay. Maybe I won't touch it, but the temperature probe on this beaker setup, the channel 1 temperature is the temperature probe at the top of the solution. Temperature 2 is the probe at the bottom of the solution. And I believe I have the same setup on this one. I just want to make sure before we stop. Yes. So on this setup, temperature on top is going to be the probe on top, and the temperature on bottom is the probe on bottom. So those are your temperature readings as you go. So I'm going to put the blue ice cube, both of these are identical blue ice cubes. I'm going to put the ice cubes into the beakers and then let this run. So if you're ready, you can go ahead and start your experiment and get ready for your timer. And I'm going to go ahead and put those ice cubes in until they melt. At this time, I want to make sure that I clarify. I was incorrect about the temperature probes for beaker 1. So over here on beaker 1, this bottom temperature is going to be the top part of the solution's temperature, and the red channel is going to be the bottom part of that solution's temperature. So make sure that you adjust any labeling that you need while you're collecting your data, because I had those flip-flopped. So again, the bottom channel is the top part of the solution, and then the top reading is the bottom part of the solution in beaker 1. just to kind of address what you're seeing right now in Beaker 2. Beaker 2 is having some really drastic temperature changes. And I think the reason why is because there's an ice cube sitting right on this probe here. So I'm just gonna kind of nudge that ice cube off of that probe because I think it's going to be affecting the data just a little bit. And I'm gonna make sure that the ice cube is not touching the probe here. Okay. Yeah, notice that I moved the ice cube off of the temperature probe and that kind of took care of the beaker on the right-hand side. At this point in time, the beaker on the right, test tube 2, the ice cube is about half the size as the ice cube in beaker 1. Remember, both ice cubes were initially identical. So at this point in time, there is one that is melting faster than the other. Okay, at this point in time, beaker 2 has just a little bit of ice left, and beaker 1 has significantly more. I would say that beaker 1 has about 8 times as much of its ice cubes still remaining that has not melted, whereas beaker 2 is almost completely melted. So we are just about to the end of our data collection. And let's go ahead and get ready to take those last measurements and stop your timers. Right now, at this instant here, the ice cube is completely melted in beaker 2, the beaker on the right. And then in beaker 1, we still have a lot of ice left over. So I'm going to lift up my phone, which is the camera, and give you a visual of those ice cubes. So as you can see inside of beaker 1, we still have quite a bit of an ice cube. And in beaker 2, there is no more ice cube left over. So your goal is to use this data, use your observations, and use what we've learned in this chapter about properties of substances and why layers form to draw a model that demonstrates why one ice cube melted faster than the other. So in your model, things to keep in it, you want to make sure you label your diagram. You want to indicate what types of matter are present, if they're solid, if they're liquid, if they're gaseous. And then you want to talk about how is the matter distributed. Does one part of it contain more particles than another? How would you know if it contained more than one type of particle or particles spacing between there? So you want to pay attention to how you space particles. You're going to make a key for your diagram so it's easy for me to determine what symbols or what drawings mean what. And then you're going to be answering the question, why does one ice cube melt faster than the other, based off of the data you collected and the observations you have, and why is it that you see what you see.